Welcome everyone. In this video we are going to learn important alkaloid, that is morphine. How structure of morphine is determined, that we will be studied in this video. Structure determination of morphine or structure elucidation of morphine. The class of morphine is, it is a phenanthrene alkaloid. This is the structure of morphine, and in morphine there is a phenanthrene ring-like structure, therefore its class is phenanthrene alkaloid. The molecular formula of morphine is C17H19O3N. Occurrence: morphine occurs in the family Opium poppy. In Marathi it is known as Afo. It is isolated from unripe seeds of poppy. In year 1803, Friedrich Saturner isolated morphine in pure form from opium, and that compound is named as morphium, which is the Greek god of sleep and dreams. Therefore, its name is morphine. In 1952, Marshall Digges synthesized morphine in laboratory in the pure form. Properties: morphine, it is a colorless crystalline solid having bitter taste, and the most important point is that it is a habit forming substance. Therefore, there is a ban on morphine. Its melting point is 247 degrees Celsius. It is optically active compound and it is a Leo rotatory compound. Although morphine has banned, but its derivatives are used in medicines for anesthesia. That is, although morphine it is banned to sold in market, the derivatives of morphine are used in medicine. Then isolation of morphine from opium. That opium seeds that are kept in boiling water. After that, water soluble salt contains alkaloid salts, that is morphine, and insoluble residue, that insoluble residue is removed. This water soluble salt contains morphine salts. Then milk of lime, that is calcium carbonate solution, is added in it. Then calcium salt of meconic acid gets precipitated out, which is filtered, and the filtrate contains that morphine. In that filtrate, ammonium chloride is added, the calcium chloride is removed, and it is kept aside for several days. Then crystals of morphine are obtained, and that crystals are then purified by recrystallization with alcohol. This is isolation of morphine from opium. Then constitution of morphine. The constitution of morphine, it is determined by following steps. The first step is determination of molecular formula C17H19O3N. Then next step is detection of unsaturation, that is presence of double bond. Then nature of oxygen atoms present in morphine. There are 3 oxygen atoms, out of 2 are present in the form of hydroxy group and 1 oxygen is in ether form. Then nature of nitrogen atom. In morphine there is 1 nitrogen atom which is tertiary in nature, that is presence of tertiary amino group that we have to prove. Then degradation studies. With the help of degradation studies, morphine contain phenanthrene ring structure that have to be proved. Then position of hydroxy groups and double bond, nature and position of the side chain, and synthesis of morphine. These are the steps by which the structure of morphine is elucidated. The first step is determination of molecular formula. By qualitative and quantitative analysis and by molecular weight determination, molecular formula of morphine is derived, which is C17H19O3N. Then detection of unsaturation, that is presence of this double bond. It is determined as follows. Upon catalytic hydrogenation, it gives dihydromorphine, which indicates there is a presence of carbon double bond carbon. This is a free carbon double bond carbon, which is proved by catalytic hydrogenation reaction. Morphine, upon hydrogenation, in presence of catalyst, it gives dihydromorphine. Nature of oxygen atoms. Upon acetylation, morphine forms diacetyl derivative, which indicates presence of two OH groups. In morphine, there are these two OH groups and it forms diacetyl derivative, that is, there are two OH groups in morphine. Morphine forms monosodium salt with NaOH and also it gives violet coloration with FeCl3 solution. That indicates morphine contains a phenolic OH group. Out of these two OH groups, this OH group is phenolic OH group as it is present on aromatic ring, and this OH group is not present on aromatic ring, therefore it is alcoholic in nature. And it gives violet coloration with FeCl3, that is, there is a one phenolic OH group. Upon methylation, morphine gives codeine, which is monomethyl ether of morphine, and which not gives ferric chloride taste. That is, this OH group upon methylation forms monomethyl derivative, and it not gives the FeCl3 taste, that is violet coloration taste. This also indicates presence of phenolic OH group in it. The another OH group, it is a secondary alcoholic group. This is secondary alcoholic group. And when treated with halo acid, the OH group is replaced by halogen atom. This also indicates presence of alcoholic OH group. And third oxygen atom must be present in the ether form. This oxygen is in the ether form. Then nature of nitrogen atom. Upon exhaustive methylation, morphine requires one molecule of methyl iodide to form quaternary ammonium salt, which indicates nitrogen atom is tertiary in nature. This is the nitrogen atom and it requires only one molecule of methyl iodide to form quaternary salt. Thus, this nitrogen atom, it is tertiary in nature. This is the reaction. Morphine requires one molecule of methyl iodide to form a quaternary salt. In Hershey-Meier's method, morphine releases one molecule of methylamine, which also indicates presence of N-methyl group. This is presence of N-methyl group which is detected by Hershey-Meier's method. This is the reaction. Morphine, 1 mole of morphine gives 1 mole of methylamine, that is presence of N-methyl group in the morphine. Then degradation studies. Upon zinc distillation, morphine gives phenanthrene, which indicates morphine contains fused carbocyclic like phenanthrene. Morphine upon zinc distillation gives phenanthrene. Such type of ring structure is present in the morphine. Then Hofmann degradation of heroin. When morphine is acetylated, then we get diacetyl derivative of morphine. And diacetyl derivative of morphine is known as heroin. It is also sold in market as heroin. This is also habit forming chemical. Its molecular formula is C21H23NO5, which is formed by acetylation of morphine. And this heroin, upon treatment with methyl iodide, gives heroin methiodide, and which upon Hofmann degradation gives dihydroxyphenanthrene, which is known as Morphol. And that Morphol contains phenanthrene ring and two OH groups at ortho positions. And the structure of Morphol is confirmed by synthesis. This is called synthesis of Morphol. This is 3,4-dihydroxy 2-nitrobenzaldehyde. When it is treated with phenylacetic acid, we get that condensation product. That NO2 group, it is reduced and followed by diazotization, we get diazonium salt, which upon Pschorr condensation followed by heat, we get that dimethoxy product, and when treated with HBr, we get the Morphol, that is dihydroxyphenanthrin. And formation of that Morphol indicates that phenolic OH group is present at C3 or C4 of the phenanthrin. This is position number 1, 1, 2, 3 and 4. This is 3,4-dihydroxy product. Therefore, OH group should be present at position number 3 or position number 4 of the phenanthrin. Then Hofmann degradation of codeine. Codeine is nothing but methyl ether of morphine, and this codeine, when treated with methyl iodide, we get codeine methiodide, which upon Hofmann degradation gives alpha codimethine. And after Hofmann degradation, the number of carbon atoms are same and nitrogen atom is present in the product. Codeine methiodide, alpha codimethine. In both cases, the number of carbon atoms are same and nitrogen is also present in the product. And when nitrogen is present in the product, which indicates nitrogen atom is present in saturated heterocyclic ring, then only after degradation nitrogen is remain in the product. For example, this reaction, in that case this is a saturated ring, nitrogen is present in the saturated ring. After methylation we get that quaternary salt, and followed by Hofmann degradation the nitrogen remains in the product, and this indicate nitrogen is present in the fused saturated heterocyclic ring in morphine. Then we have to detect presence of ether ring. The alpha codimethine, when heated, it is converted into beta codimethine, and both alpha codimethine and beta codimethine upon Hofmann degradation, that is treated with methyl iodide, excess methyl iodide followed by hydrolysis, we get the product methyl morphinol, and that methyl morphinol contains methoxy group and ether bridge. When methyl morphinol is treated with hydrogen bromide, morphinol is obtained, which contains free phenol group and OH group. And when it is treated with sodium in ethanol, we get the Morphol as the product. The same reaction can be obtained by another route. When methyl morphinol is treated with sodium in ethanol, we get methyl morphol, which contains free phenol and methoxy group. In that case, when it is treated with HBr, we get free phenol and OH group. In that case, we get free phenol and methoxy group. And when it is treated with HBr, we get the Morphol as the product. And that reaction can be represented like this. Methyl morphinol, which contains methoxy group and ether bridge, when treated with HBr followed with Na reduction with sodium in ethanol, we get Morphol as the product. And this is methyl morphol. When treated with Na in ethanol, sodium in ethanol, we get methyl morphol as the product. This is methyl morphinol and this is methyl morphol. Look at the structure. There is a ether ring, and in this case the ether ring is spread, we get methyl morphol, which when treated with HBr, we get the Morphol as the product. This is methyl morphinol. Upon hydrolysis gives 3,4,5-trihydroxyphenanthrin, and this reaction indicates that morphine contains phenanthrin-like ring structure, phenolic OH group and ether bridge in the ring, and the OH group taking part in the ether formation as it is in position number 4. This is position number 4, that OH group takes part in the ether ring formation. Therefore, the phenolic OH group must be present at position number 3. This is the position number 3 at which phenolic OH group is present. Then position of secondary OH group. Codeine, that is methyl ether of morphine. When treated with methyl iodide, we get codeine methiodide, which upon acetylation gives 3-methoxy-4-acetoxyphenanthrin. On the other hand, codeine upon oxidation gives codenone. When it is treated with methyl iodide, we get codenone methiodide, and which upon acetylation gives 3-methoxy-4,6-diacetoxyphenanthrin. This is 3-methoxy-4-acetoxyphenanthrin, and this is 3-methoxy-4,6-diacetoxyphenanthrin, which are the products obtained by these reactions, and that products indicate that the secondary OH group is present in the third ring and probably at position number 6. Thus, the framework of morphine is like this. This is the phenolic OH group at position number 3. There is a presence of ether linkage by using hydroxy group at position number 4. This is the ether linkage. And the secondary OH group is present at position number 6. There is a phenanthrin ring-like structure, and this is the framework of morphine. The total unsaturation in morphine, by taking the molecular formula in Grant, we get the site of unsaturation is 9. For phenyl ring, there are 4 sites of unsaturation. We know how site of unsaturation is determined. And for phenyl ring, there is a 4 site of unsaturation. For these 3 fused rings, there are 3 sites of unsaturation, and there is a presence of 1 carbon double bond carbon. Therefore, there is a 1 site of unsaturation. Thus, there are total 8 sites of unsaturation, and a remaining site of unsaturation is 1. And remaining 1 site of unsaturation indicate that there is another fused ring in the morphine. Let we see. Position of carbon double bond carbon and that ethyl amine chain. This is codeine monomethyl morphine. When it is treated with phosphorus pentachloride, we get chlorocodeine. Chlorocodeine has 4 isomers like this. The first isomer is like this. There is a double bond, alpha beta unsaturation. There is a chlorine atom at this position. When treated with acetic acid, that chlorine is replaced by OH group. We get the codeine. And these are the remaining 3 isomers. These are the positional isomers like this. When treated with acetic acid, we get OH groups. Chlorine atom is replaced by OH groups. This is codeine, this is isocodeine, this is pseudocodeine, and this is pseudoallocodeine. Upon oxidation, codeine and isocodeine gives codenone. That are the partial structures of codenone. These structures are possible for alpha beta unsaturated structure. That is, OH group is present next to the double bond. And thus OH group is present at position 6, carbon atom number 6, and double bond is present at C7 and C8 in morphine. That is the carbon atom number C7 and C8, and thus secondary OH group is present at position number 6. Then next step is position of ethylamine chain. The following positions are available to attack ethylamine chain. These are the positions at which ethylamine chain should be attached. One of the compound is studied, that is thebaine, which is also opioid analgesic, and its structure is like this. This is the structure of thebaine, and in thebaine, this is the position of N-methylamine chain, and this is the position number 14, and thus position number 14 is not available for side chain. The difference between these two structures is that there are OH groups and there are methoxy groups. This is the structure of thymine. And thus position protein is not available for the chain. Then codeine upon mild oxidation gives hydroxycodeine, which upon Hofmann degradation gives ketocodimethine, which upon acetylation gives methoxy-diacetoxyphenanthrin, and which upon oxidation gives methoxy-acetoxyphenanthraquinone. Look at that structures, methoxy-acetoxyphenanthraquinone. And therefore the chain should be present at C9 or C10th position. These are the positions for N-methyl side chain. The ninth position is the most probable position for N-methyl chain because it is confirmed by biosynthesis, and the other side of the chain is attached to either C13 or C5. And upon Beckmann transformation of codenone, the product obtained show that C13 is the attachment site. And as codeine is methyl ether of morphine, the structure of codeine is like this. This is the structure of codeine, which is methyl ether of morphine. And this is the position of N-methyl side chain. And thus the structure of morphine is like this. This is the structure of morphine. Morphine contains two hydroxy groups, one at position number 3, another at position number 6. That OH group is phenolic OH group. That OH group is secondary OH group. The ether linkage is present in between 4 and 5. This is the N-methyl side chain, which is present 13 and 9th position. And the double bond is present between C7 and C8. And there is a phenanthrin-like ring structure. And thus the structure of morphine is confirmed by analytical evidences. And that structure is then confirmed by synthesis. The synthesis of morphine by Gibbs et al. 1986. 2,6-dihydroxynaphthalene, when treated with benzoyl chloride, there is a protection of one OH group takes place and monobenzoate derivative is obtained, which upon nitrosation we get nitroso derivative. Upon reduction, nitroso group is converted into amino group, which upon oxidation gives that product, diketo product. Upon reduction, that keto groups are converted into OH groups, then methylation followed by debenzylation. Such type of product is obtained. Again, nitrosation, reduction and oxidation steps. Again, same type of arrangement takes place. We get two keto groups at this position. Upon Michael condensation, such type of product is obtained. Upon oxidation, saponification, decarboxylation, that group is converted into CH to CN group. Then there is a Diels-Alder reaction, cycloaddition reaction, such type of product is obtained. Upon reduction, we get such type of product. Glucose reduction, methylation followed by reduction, hydrolysis, again treated with KOH. These are the steps of the synthesis. Look carefully. Then opener oxidation followed by bromination, then treated with 2,4-DNP. After that there is a reduction, bromination, again it is treated with 2,4-DNP. We get one bromo, codenone, reduction, then we get codeine, and then we get the morphine. These are the steps of synthesis of morphine. The structure of morphine is confirmed by both analytical and synthetical evidences. The synthesis of morphine you should see carefully. And thanks for watching this video. Thank you very much.